Okay, I would definitely like to go over these methods and formulas in class. I started to go over this one today. This is what we were looking at in Maple, how to find the volume of a solid of revolution. And we looked at it, actually we looked at both of these. We looked at one where you had a solid that didn't have kind of like a hole in it, and this is where you had a solid that did have something taken out of it. So we kind of looked at both of those. The only thing we really didn't look at was a vertical axis of revolution. We looked at a picture, but we didn't look at how that would change the radius. How that changes the radius, you'll see, is you would write that radius as x, because it's a horizontal line, as a function of y. So we would be looking at a formula similar to one of these. If you didn't already do it, you might want to rewind and write down those formulas. And now we are going to start to use them. Okay, so in most of these, what we're going to do, it says here, is set up and evaluate an integral that gives us the volume of the solid. And it doesn't say to evaluate it, but you'll see that in most of these I'm going to have you use your calculator to evaluate the integral anyway. What you notice in these pictures is something like this. This is a representative rectangle. Think about Riemann sums. You could probably tell this would be a rectangle you would draw if we were using a midpoint sum. A bad little point there, but that's showing that the height of that rectangle came from the midpoint of this interval, whatever this stretches from and to down here. And if you would swing this around, in this case the x-axis, if we're going to revolve this around the x-axis, that would give you one of those discs that we were looking at in Maple when we had the what was it called, partitions, when we showed like 6 partitions and you can actually see the different discs. That's what this would turn into when you revolved it around the x-axis. So for right now, to set up the integral, let's kind of try to get used to drawing what the whole solid would look like. So maybe yellow's a little light, but it's what I chose. So what does this look like if you picture it 3D? It kind of looks like an M&M that's chopped in half down the middle. Alright, and what you need for each one of these things is the radius, because our volume is going to be pi times the radius. And I think I had this as a capital R, but when it's only one R, we don't have to be that careful. Our pi times the radius squared, and because we're going around the x-axis, the radius is this right here. It's the height. And this is a y equals a function of x. Right? So that's your radius. This is our r of x. Alright, so where are we going on the x-axis? We're going from 0 to 2. So again, it's pi times the integral from 0 to 2 of 4 minus x squared squared. And this says just to, oh no, set up and evaluate. So evaluate the integral, but use your calculator. If you still need help with using your calculator to find an integral, let me know. But you should have gotten 17.06 with the 6 repeating. Turn that into a fraction, and you get 2/56/15. And now don't forget that there was a pi in front of that integral. Okay, next. The directions here actually said to revolve the shape around the y-axis. And you can tell that by the representative disk that they're drawing, or the representative rectangle, that this is being swung around this axis. So let me see if I can draw... Take that axis that you're revolving around, try to make that look like a mirror. Alright, now I'm not going to shade it in because I want to always keep track of what the original shaded part was. But this is what it looks like. To me that reminds me of one of those tops of one of those funny looking churches. Whatever, I hope I didn't just offend somebody. But that's what that looks like, some kind of Russian building or whatever. Now the important part is, how are we going to find this volume? Well, now the volume, it's still going to be pi r squared, but what kind of r is this going to be, and what are we going to, what kind of bounds are we going to be using? And I'm kind of giving it away because I'm leaving it blank. But the radius, any radius that you draw here, it's a horizontal line, right? Horizontal lines are x's. So if we have x as your radius, then it must be some function of y. Well, if you look up here, x is a function of y. It's negative y squared plus 4y. So this is r of y dy, which means we need y bounds. Look at your shaded part. Your shaded part goes from 1 to 4. So, easy, right? Your volume is pi times the integral from 1 to 4 of, and I'm going to write this the opposite way so I don't have to start with a negative, 4y minus y squared radius squared dy. And again, I'm going to put this into my calculator. Yeah, that wasn't annoying. I'm going to put this into my calculator and turn it into a fraction and then put the pi on there. Now I should probably also say, whenever you're doing these, think about, is it something you could use your calculator for and not get an irrational number? If you were going to do this by hand, the first thing you would do is square this quantity. So you get 16y squared minus 8y cubed plus y to the fourth. That's just a polynomial function. A polynomial function is only going to give you fractions. We're going from 1 to 4, and that's not going to give you anything irrational. If it is going to give you an irrational answer, we're going to have to do it by hand, because your calculator won't give you that exactly. Okay, now for number 12, I'm going to see if I can make time to go through all 4 of these, especially since we're using our calculator to integrate. Now, I have a different page for each one of these, A, B, C, and D. Notice these are different axes of revolution. So the first time we're going to revolve this around the y-axis. So every time, though, I want to draw the portion of this parabola, y equals 2x squared, and I want to bound it by y equals 0, which is the x-axis, and x equals 2. So if you're not sure what to shade in, draw these 3 things first, and then shade what touches all 3. So let me pick a good color. Alright, I know that my parabola, I'm actually going to plot some points. If I plug in a 0, I get 0. If I plug in a 2, I get 2. I'm sorry, a 1. If I plug in a 1, I get 2. If I plug in a 2, 2 squared is 4, 4 times 2 is 8. So I'm getting this really narrow, skinny parabola. Now the reason that I didn't swing it on the other side as well is because I want it to be bordered by that, and y equals 0, and x equals 2. Knowing what 3 things it's bordered by gives me my shaded part. So some of you may have been tempted, or just assumed originally, that you were going to be shading in this part up here, and I guess I went too high, so maybe I'll try to get rid of some of that. But that's not the part that you're shading. It's just the things that are bordered by these 3 graphs. I'll draw it better next time. Just pretend this stops up here at the point 28. Alright, so for A, I'm going to be revolving this around the x-axis. So let's try to draw that. I'm sorry, y-axis. I can't say what I'm thinking. Alright, so I'm going around the y-axis. So I'm going to draw my mirror of this shaded part over here. And I'm going to try to make it look a little 3D-ish. And we looked at something like this in class. It's a cylinder with, you know, a parabolic shape hollowed out of the middle. So, how do I get this integral? We'll go back to your formulas if you need to. Pause this if you need to look. Remember, I'm going to put them together. I'm going to do the outside radius squared. So let me make it a darker orange. So my outside radius squared, let me draw a few of them. Here's my outside radius. Here's my outside radius. Here's my outside radius. Do you see what your outside radius always is? No matter where I draw it? It's always the line x equals 2. Always. Okay? Now, what is my inside radius going to be? My inside radius, maybe make that darker. My inside radius is in here. I'm going to pick a lighter color. So here's an inside radius. Here's an inside radius. Here's an inside radius. Now that varies, right? But notice it's a horizontal line, so I still need a x equals for that little inside radius. Well, x equals what? Well, I'm touching the function, and this is the function, right? Y equals 2x squared is the function. So if y equals 2x squared, how do I know what x equals? Pause it, think about it, because I'm going to tell you. Alright. You solve for x. So x squared is y over 2, so x equals plus or minus the square root of y over 2. Alright, so why am I only writing the positive? Well, because look at all the radii where I drew them. I only drew them on this side. So this is going to give me the 1/2 of the parabola. The negative would give me the other half on the other side. Alright, so the square root of y over 2. So now I have, all you have to do is figure out which radius is which. This is my inside one, and this is my outside. So I'm going to take my outside radius and square it minus my inside radius and square it. And I want to integrate all of this with respect to y, so I want my y bounds. Make sure you know what they are. And now I can plug this into my calculator. And just so you know, I think it would be quicker to plug into the calculator. What I'm going to do is actually square that, and actually, whoops, square that. No, I was right the first time, y over 2. And this is what I'm going to put into the calculator and let it integrate it for me, because again, this is just going to give me 4y, like a 4y and a y squared. It's not going to give me anything irrational. Okay, I don't know if anyone had been yelling at me the whole time, but where's the pi? See, if you guys were in class, somebody could have gotten a ticket. I remembered it when I went to put it in after I used the calculator, so my answer is 16 pi. I think I'm going to stop this here. If you want to try B, C, and D yourself, please try. I'm going to, or at least try to get them started. You know, what's the worst you can do? Make a mistake and learn from it. And then I'm going to put B, C, and D in a different video.